Hi, my name is Adrian. Claire and I are here today to tell you about our project called Typannot. Typannot is an innovative typographic system to transcribe sign languages. But before telling you more about it, I will briefly introduce our research team. Unfortunately, as Yanni said, we recently received the harsh news of the loss of Dominique Boutet, one of our members. He was one of the founding members of Typannot, and his enthusiasm and work will be sorely missed. We would like to send a simple message of caution. Dominique was middle-aged, he was in good health, and he wasn't considered as someone at risk. So let us all be vigilant and work together on stopping the spread. Let's go back to our topic, Typannot. Typannot is a design-based research project. It all started as a student project in the Art and Design School of Amiens. The student is Claire, who's with me today. With time and by encountering new people, Typannot evolved from a master's degrees project to a research team involving 10 steady members working together for the past 10 years. Today, we are very lucky to have within our team 4 linguists, a developer, 3 designers, 1 sign language expert, and a type engineer. But gathering people is not enough. You also need space and time to work. That is why the members of our team meet every Friday and for the whole day work together. So what we're going to show you today is the results of 10 years of investigation, prototypes, and iterations. And there has been a lot. But now that you know a little bit more about us, I'm going to walk you through the key steps of our presentation. We will start by introducing sign languages and the issue of the annotation of sign languages. We will then jump straight to the topic by showing you the Typannot solution, and we will explain the depths of its typographic system. To support this, we will show you our method and research process. To finish, we will show you our current work to make Typannot fully efficient and accessible. But first, I'm going to pass it on to Claire so that she can tell you a little bit more about sign languages.
Thanks, Adrienne. I don't know if you see me, but it would be nice for sign language. So, okay, sign languages. All of you have at one point come across sign languages by seeing people signing on the streets or by seeing a TV program translated into sign language. Even though everybody is familiar with the language, people often don't know that there are 142 sign languages across the world, which means there is no universal sign language. There are nationalities. For example, in French, the sign for, I hope you see me, the sign for hello is, and in Japanese, the sign is, okay. And all those differences come from cultural heritage. This makes sign languages fascinating to study. In fact, there are a lot of components to study in sign languages. Meaning is carried by multiple parameters. You have the Handshape, the most well-known and studied, is one of them. The position of the hand is another parameter. You also have the movement and facial action. All of those parameters can act simultaneously to create meaning. In that regard, we say that sign languages are multilinear languages, unlike spoken languages that are based on sounds, in which only one sound can be produced at a time. I'm sure you can start to imagine how complex it can be to study a multilinear language. To give you an idea, Adrienne is going to briefly show you how linguists deal with this question.
Thanks, Claire. In order to do that, I'm going to start by telling you a little bit more about annotation. To study the relationship between the different aspects of language, linguists first need to annotate pieces of speech. To do so, they use softwares like this one called Elon, in which is imported a sample of video. How does it work? Well, first, they need to transcribe the meaning of the sign used in the video. To do that, they often translate them into their own language, English, German, French, depending on their nationality. But by doing so, they create a gap between the action that were made by the signer and the information that is transcribed on the software. Why is that? Well, because the alphabet that they are using to transcribe speech is based on sound. A letter carries acoustic information, and using sound-based letters to transcribe corporal actions doesn't seem to be ideal, especially if you want to have a structural analysis on the language. So, is there another solution? A transcription system closer to the language? Well, several systems have been created in this regard, one of them being sign writing. Based on a logographic approach, it offers a visual representation of signs. This makes it rather intuitive. But it isn't the most efficient system for annotation and research purposes, simply because what you can see on the board are individual glyphs. In other words, the different parts of the glyph cannot be extracted. These glyphs work as a whole, which limits a researcher's ability to analyze the individual components of a sign. Hamnosis offers this possibility by dividing information into smaller pieces so that they can be analyzed in a finer manner, which also offers the possibility to request within a transcription specific components of signs. And that's how you can really start connecting things together. But as you can see, it isn't particularly easy to read, and it's quite bulky to use. One other point to highlight is that both of those systems offer an outer representation of the sign, meaning that they describe the outer shape that can be seen on the video, but they do not carry the structural information of sign languages. If for spoken languages, this information is sound, what would it be for sign languages? Well, something like the structural information of the body itself, right? These issues beg the question, is it possible to create an annotation system that allows a complete description and searchability while still being easy to read? Would it be possible to add a deeper level of information to truly represent the essence of sign languages? In the Typannot team, we believe it is. And we have dedicated our time and effort to make it a reality. To be able to solve these complex issues, we decided to consider the question at its roots. What is it that makes a sign? What do we do while signing? The answer is quite simple. We move different parts of our body, which means we're using the joints, the articulations in our skeleton to create shapes that will carry meaning. That is why the structure of the Typannot system is based on an articulatory level. And this is how it works. Here, you have an example of a handshape. And this is the corresponding Typannot glyph. Or to be more precise, it's one of the representation possible with the Typannot system. It's a composed glyph. Why composed? Because we also have a decomposed display of that same handshape included in the type font. This is what it looks like. Each square, we call them generic characters, carries an articulatory piece of information. Here, you can see the generic glyphs corresponding to the index. it's currently curved and semi-closed. And here, the generic characters for the thumb. It is opposed, semi-closed, and in contact with the index. But I'm sure you're asking yourself, how is that included in the same type? How does that work? Well, it's fairly simple. We're using open type features to create ligatures, just like when you're linking an E to a T, but we're pushing it a step further. All our generics can be ligatured in a composed glyph. And this can be achieved by simply switching from one display to the other at any time in any software, which means that we have a glyph that's compact and easy to read, as well as a very detailed description of all components. And all those pieces are searchable. And that opens a lot of possibilities in the way that sign languages can be analyzed. Here are some of the composed glyphs created with the Typannot font. This is only a sample, because if we had to look at every possible combination, it would take us quite some time. That's what we have been able to create. And before getting into further explanation about what we're working on right now, I'm going to pass it back to Claire so that she can tell you a little bit more about how we got here.
Yeah, it looks quite simple when presented that way. But in order to achieve this result, we've had to go through a lot of thinking, trying, and iterating. These are the key steps that we followed. First, we started by analyzing what had already been done by way of analysis of sign languages. We extracted the formula that showed itself to be the most efficient at describing the different pieces of signs. This formula was set up by Icarus and Brentari and based on 9 sign languages. Then, we ran some tests using this formula and worked on making it more exhaustive so that it would work for more than the initial 9 sign languages. We also worked on injecting within this formula our articulatory information. This is a quick overview of the structure of our formula. First, you have the parameter, the hand, the position, the movement, the face. Each of the parameters are divided into different parts. If we take the example of Handshapes, you will find each finger, index, middle, thumb, etc. On each of these parts can be applied certain types of variations. Each finger can have different shapes or different angles. And these variations each have a set of values. The shape for the fingers can be flat, curved, or bent. This organization and description enable us to be precise, yet concise in the description for signs. After testing the formula and getting confident about its structure, it was time to create our generic characters. Here is our generic set for handshapes. Using these, you can transcribe any handshape in any language. Then, it was time to get into the real deal, for us, the design of our composed glyphs. Here you can see an early sketch, an intermediate version in RoboFont, and our updated results. But there was something else that needed to be worked on. If you take all our generic characters for handshape and combine them into all the handshapes a human being can make, we end up with 291,600 composed glyphs. And how can you actually design 291K glyphs within a lifetime? Well, we decided to think about the fingers as separate elements and extracted all the different shapes of each finger. This is what it looks like. Then it was time to create rules to combine them. For that, we used typographic engineering techniques in order to get an automatic composition. Here is how it works. Great. We can now create our nearly 300,000 glyphs. But wait, isn't it a little bit too much? 291,600 glyphs. Yes, it is. Because this number of combination exceeds what current technologies allow. OpenType offers 64,000 spaces. So what's the solution? How can we select a maximum of 60K handshapes? How can we define which are relevant or which might become relevant in the future, because sign languages, as all languages, evolve? Well, first we decided to go back to the original study of Ekeris and Brentari. They had defined a set of 237 handshapes for 9 languages. We worked on extended that set to obvious need in a wider spectrum of languages, and we came up with 990 that are widely used. But that's far from being enough. So how do we select the rest? One thing that we could do is to ask some linguists to work on formulas and rules to define which shapes should be added. But then a minority gets to decide which should and which shouldn't. And it doesn't seem to be the richest process. Another thing that we could do is to gather all the needs of all the linguists currently working on sign languages. But how do we do that? Well, Adrian is going to show you a tool that we have been working on that can solve this problem and offer great solution in the act of transcribing.
Yes, this is an important topic. Creating such a font is a great achievement, but thinking about how to make it fit what is available is the priority. This issue brings another question: how we will be properly able to use all those glyphs that we have created. To respond to both of these issues, I'm now going to show you the digital user interface that we have been developing. This is Typannot keyboard, and this is how it works. As you can see, you can select the different components of our formula and see the corresponding result. That being done, you can send the glyph to any text document or software. This offers a simple and efficient tool to use the type. But this device also offers an answer to the completion of her type. In this keyboard are loaded the 990 pre-selected signs. But if during her work, a linguist comes across a glyph needed for her transcription that isn't in the initial library, we will give her the opportunity to request it so that she can add it, so that we can add it to the next update of our font. Typannot font will basically become an open sourced, or more specifically, a research sourced font, in which can be found all the glyphs that all the researchers have used in their work. And there are currently 63,000 places left, so that should hold up for quite some time. That's all good. But if you go back to what we have started with, you will remember that sign languages are multilinear, which means that Handshape isn't everything. That is why the articulatory logic and the glyphic system that we have developed for Handshape has also been applied to the other parameters of sign languages: the position, movement, facial actions. Here is our very recent keyboard prototype for the arm position. We're not going to describe everything here. All you need to know is that it works with the same articulatory principles as Handshape. And thanks to these similarities, we can now connect the hand to the arm and analyze the information carried by a sign within the spectrum of the whole upper segment. In the linguistic departments of Typannot, we have an intuition. The intuition that the articulation of the arm carries some semantic pieces of information, which means that the meaning carried by a sign isn't restricted to the end. Being able to annotate the hand and the arm using similar logic is going to offer the possibility of analyzing the relationship between these two parameters. And we are sure it will bring another level to the analysis of sign languages. This has been the life work and dedication of our dear friend Dominique Boutet. And we're very determined to follow up on his ideas and to create a powerful tool to understand sign languages. Thanks all of you for your time, and all the Typannot team hopes you have enjoyed this presentation.
Thank you very much for this amazing presentation, amazing work of yours. I'm waiting for questions, and while waiting, if I understand well, your system can be used in some sense like APA, like a phonetic alphabet, so that one person is speaking in one language, and then either a machine or another person writes this down in Typannot, and then an automatic translation can produce this in another language. So it could serve as an interface between sign languages for automatic translation. Is there already a system for automatic translation between sign languages?
Claire, I don't know if you have any knowledge of such an automatic system. I personally don't.
APA, yes, it's in French. Tu sais, les phonétiques, l'alphabet phonétique pour toutes les langues. But no, there is no. Typannot is working on for every language, so it's like an APA.
Well, the real interesting point with the body is that we're more or less all made the same way. So whether we speak a language or another, if we're transcribing the movement and the positions of the body, this can be analyzed like globally, worldwide, and it's an interesting part. But for an automatic translation, it would need to include some understanding also of what we were talking, like every language has his own history, and we don't produce the same gestures for every word. So I think there could be something done, but it would require a little bit of work to make it efficient.
And do you expect the equivalent of optical character recognition, so a machine that sees signing and transcribes into Typannot?
In the future, I hope so. Yeah, we actually working on gestural input for transcribe automatically in Typannot font.
Yes, for the Handshape, we've been working with leap motion. So the function is quite simple. You put your hand and then you sign, and the leap motion is going to analyze the position, and it's going to transcribe it automatically in Typannot. This is already something we have worked on, and it works pretty well. It's also true for the arm position with mocap, but this is the setup is a little bit more complicated, and it's only very recent studies. Dominique was working a lot on mocap and on the body parts and automatic transcriptions. So it's something we're going to investigate more in the future.
And have you evaluated the system with native speakers? Because yesterday Amalia was saying that we have the S1 effect. So maybe native sign language users do not perceive it in the same way as we would.
Yeah, maybe Claudia is here. Claudia Bianchini can answer this question.
We test the Handshape with both hearing and deaf students in Poitiers, and the result was quite good. But we haven't tested the other parameters because we are working on them, so they are not enough stabilized to test them for now. But we will do it.
Okay, and a question by Cornelia.
Yes, thank you very much. You hear me?
Yes.
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 Yes, oh good. This morning it was bad. Chinese sign language, I only know very few signs, involves interaction between different body parts, like slapping under the chin to say, wait a moment, or sliding up the left arm to say German Mao, or to put both fists on one another to say work, which probably is sign language have too. Can your system describe movements like these?
Sorry, I didn't understand the sound. It was so bad.
A lot of
Go on, Claudia.
no, there was a lot of interference, so I didn't understand the question. I'm sorry.
The question by
I'm sorry.
Cornelia. The question by Cornelia
I'm
was,
copying my question to the chat.
would the system allow to describe
You
a
can read
sign
it.
that involves slapping the right hand under the chin, is the Chinese sign for wait, or sliding the right hand up the left arm, which is the Chinese sign for Chairman Mao?
Well, if you remember the different parameters that we have described, there was a hand shape, the hand position, movement, and facial action. The parameters that we have worked more on is hand shape, and the one that is still has the most work to do is movement. So basically, what we would be able to do right now is to have the hand in the right position and position it at the right place, but it also requires movement. And this is something that we have just started to work on the formula. So our work is far from being complete on this parameter, but of course we're going to work on it in the future months and years.
Thank you. And a question by Dan Harbour.
Hi, two questions. If there's not enough time, just pick whichever one you feel like answering, please. The first one is kind of related to the question we just had. If you've already exceeded the 60,000 figure by a factor of 5 just for Handshape, how are you going to manage to do face and hand and then all the other things? So that's question one. Sorry to sound negative, but this is such fantastic work. It would just be a shame if 60,000 were what limited it. So that's the first one. The other one is the composition that you've got of your characters reminds me of this Chinese encoding system where complex characters are broken down into very few shapes and then they're combined. Was that the inspiration, or did you just converge on the same thing? Or is there any point of contact there at all? So 2 questions, whatever you feel like answering.
I'm going to answer the first one. It's fairly simple. we will be basically doing different types for each parameter. So you will have a type for Handshape. We will have 64K spots to use, and we will have a type for the arm position, a type for the facial actions, and so on. For facial action, it's going to be very tricky to be able to symbolize all the little movements that can happen in the mouth. So what we're thinking right now is to divide the face into two parameters: what happens with the eyes and the eyebrows, and what is happening with the mouth. So we might have two types for facial actions, but this will allow us to have 64K glyphs for each of those types, and then they can be used together. And that's for the first. If someone wants to answer the second one about the Chinese inspiration.
Claire, t'y vas?
No. Claudia.
Ça, c'est un travail de. It's to work for designers, not for linguists for the moment.
Okay, so if they're not here,
Okay,
so in principle, you could actually, you could do all 300,000 of the hand shapes as well if you were willing to divide them up into like 5 categories.
Yes. Yeah.
Yeah.
But
That's
to
cool.
answer quickly about the design, of course, we have researched and analyzed all the different systems that were used to see which one could offer some solutions for such a complex tasks. And of course, the Chinese system and the combination of different characters was one of them. Yeah.
Thanks.
Okay, thank you very much for this excellent project.